On a cold morning in 1969, the sound echoed across Daytona. Massive V8s thundered down the banking at more than 190 miles per hour. Every team knew one thing: if Ford's newest engine survived, everyone else was racing for second. But what almost nobody knows is that the engine dominating NASCAR wasn't supposed to exist in the first place. It was born out of desperation. It cost Ford a fortune. It forced the company to rebuild brand new Mustangs by hand, and despite proving itself on America's biggest racetracks, it was canceled almost as quickly as it arrived. Most people remember the Boss 429 as one of the rarest muscle cars ever built, a collector's dream, a $1 million icon. But the real story isn't about the car, it's about one of the most advanced big block V8s America had ever produced, an engine that won races, terrified competitors, and still couldn't survive the business reality that created it. You think you know the Boss 429 story? Not like this. By the late 1960s, Detroit was locked in an all-out horsepower war. Every major manufacturer wanted to dominate both the showroom and the racetrack. Chevrolet had its legendary 427S, Chrysler unleashed the fearsome 426 Hemi, Ford had powerful FE engines like the 427 Side-Oiler, but there was a problem: NASCAR was changing. The old FE platform had reached its limits. Chrysler's Hemi was proving nearly unbeatable on the superspeedways, and Ford engineers knew they needed something entirely new if they wanted to reclaim the crown. The pressure was immense. Ford's racing reputation hung in the balance. After dominating Le Mans with the GT40 program, the company desperately wanted to maintain its performance image. Losing to Chrysler week after week wasn't just embarrassing, it was costing Ford sales, prestige, and credibility. Something had to change. The answer became a secret project inside Ford, known simply as the 385 series. It would eventually produce several famous engines: the 429 Thunderjet, the 460, but one version stood above all the others, the Boss 429. Officially, it displaced 429 cubic inches, or about 7.0 liters. It featured a 4.36-inch bore and a 3.59-inch stroke. Those numbers weren't chosen by accident. The large bore allowed engineers to install enormous valves, while the relatively short stroke kept piston speeds manageable at high RPM. Engineers call this an over-square design: big bore, short stroke, perfect for high-revving performance. That combination gave the engine something every racer wanted: the ability to breathe. And breathing was exactly what made the Boss different. Instead of conventional wedge-shaped combustion chambers, Ford engineers developed massive semi-hemispherical chambers with canted valves. The intake and exhaust valves weren't directly opposite each other. They were angled in multiple directions, creating straighter airflow into the cylinders. Think about it like this: air doesn't like turning sharp corners. Every bend in the path robs power. Ford's engineers understood that eliminating restrictions meant installing valves at optimal angles, even if it complicated everything else. The intake valves tilted one direction, exhaust valves another. The geometry created nearly straight paths for incoming air and fuel. Air entered easier, exhaust escaped faster. The engine could rev higher while making more power. On paper, Ford rated the street Boss 429 at 375 horsepower and roughly 450 pound-feet of torque, with an 11.3:1 compression ratio, a single Holley 4-barrel carburetor, and hydraulic lifters. But almost nobody believed that number. Contemporary dyno tests and factory insiders suggested the engine was producing well over 500 horsepower in factory trim, while NASCAR race versions easily exceeded 600 horsepower. Some unrestricted competition builds approached 700 horsepower with higher compression, aggressive camshafts, and open exhaust systems. Magazine editors whispered about the real number. Racers knew the truth. Competitors felt it on the track. Ford deliberately underrated the engine. Insurance companies were already cracking down on muscle cars, and publishing the real numbers would only make matters worse. Young drivers faced skyrocketing premiums. Parents refused to let their kids buy high-horsepower monsters. Dealerships watched potential customers walk away after hearing insurance quotes. Ford's marketing department faced an impossible challenge. Build an engine powerful enough to win races, but rate it low enough to remain insurable. The solution was creative accounting. List conservative numbers. Let the stopwatch tell the real story. But there was a problem. Building an incredible engine wasn't enough. NASCAR had strict homologation rules. If Ford wanted to race the Boss 429, it had to sell production cars equipped with the engine. Specifically, NASCAR demanded that at least 500 street-legal examples reach customers before the engine qualified for competition. That sounded simple. It wasn't. The Boss 429 engine was enormous, far larger than the engine bay of a standard Mustang. Engineers quickly realized the shock towers wouldn't clear the massive cylinder heads. The battery had to move. The suspension required changes. Even the firewall needed modifications. Nothing fit. Standard Mustangs were designed around smaller, narrower engines. The Boss 429's gigantic semi-hemi heads were simply too wide. Traditional installation was impossible without completely redesigning the car's front structure. Ford's regular assembly plants couldn't handle any of it. Production lines were optimized for volume, not custom engineering work. Assembly workers installed parts in precise sequences using standardized procedures. The Boss conversion required skills, time, and modifications that would paralyze normal manufacturing. So the company turned to Kar Kraft, a specialty engineering firm in Brighton, Michigan. Kar Kraft wasn't a typical supplier. The company had already proven itself modifying Mustangs for Ford's Trans Am racing program and developing prototypes for special projects. They understood performance. They knew how to solve problems Ford's regular engineers couldn't tackle on a production line. This job was different, though. This was hand-building production cars, hundreds of them. Brand new Mustangs rolled off Ford's assembly line with ordinary engines. Then they were shipped to Kar Kraft. Workers practically rebuilt the front half of every car by hand. Shock towers were cut apart and reshaped. Reinforcement plates were welded in. New suspension pieces were installed. The battery relocated to the trunk. Larger cooling systems fitted. Different engine mounts fabricated specifically for the giant V8. Every single car received custom metalwork. Skilled fabricators measured, cut, reformed, and welded new shock tower shapes that provided enough clearance for those massive cylinder heads. They added structural bracing to maintain chassis rigidity after cutting away factory metal. They repositioned components that conflicted with the new engine's dimensions. The front suspension got upgraded too. Standard Mustang parts couldn't handle the Boss's weight and power. Kar Kraft installed heavy-duty springs, reinforced control arms, and larger sway bars. The steering linkage required repositioning. Brake systems needed upgrades to stop the heavier, more powerful machine. Even the cooling system demanded attention. The Boss 429 generated tremendous heat. Factory radiators were inadequate. Kar Kraft fitted larger, high-capacity radiators with custom mounting brackets. Oil coolers kept temperatures stable during hard driving. It reportedly took dozens of labor hours for every single conversion. Some estimates suggested each car required 40 to 50 hours of specialized work beyond normal assembly time. Skilled craftsmen earned premium wages. Custom parts cost more than mass-produced components. Quality control demanded careful inspection. The process was incredibly expensive, and Ford lost money on nearly every Boss 429 it sold. Industry insiders estimated Ford spent anywhere from $1,500 to $2,500 per car beyond the retail price just completing the conversions. Multiply that by over 1,000 cars, and the program represented a multi-million-dollar investment with no hope of direct profit. You can probably guess what happened next, but the truth is even crazier. The street car looked almost understated. Unlike the Boss 302 or Mach 1, the Boss 429 wore relatively subtle graphics. No flashy stripes, no wild colors. Just small Boss 429 inches callouts and modest badging. Ford deliberately kept the exterior low-key, perhaps understanding that buyers sophisticated enough to want this engine didn't need flashy marketing. Underneath, however, it carried one of the most exotic American engines ever placed into a production car. forged steel crankshaft, 4-bolt main bearing caps, forged connecting rods, forged aluminum pistons, massive aluminum cylinder heads. Every internal component was built to withstand punishment. The forged steel crankshaft could handle extreme cylinder pressures without flexing or breaking. 4-bolt main caps secured the crankshaft with twice the strength of typical 2-bolt designs. Forged connecting rods resisted the intense forces of high RPM operation. The heads alone were engineering masterpieces. Their huge intake ports became known as crescent ports because of their unusual shape, allowing tremendous airflow at high engine speeds. Each intake port measured over 3 square inches in cross-section. That's massive. For comparison, most contemporary big blocks featured ports measuring 2 to 2.5 square inches. The Boss's ports flowed air like open windows, feeding cylinders with enormous volumes of mixture. Unfortunately, all that airflow created a different challenge. Low-speed drivability suffered. Large ports move air slowly at low engine speeds, reducing mixture velocity and hurting cylinder filling. The Boss loved RPM, below about 3,000 revolutions per minute. It could feel lazy compared to engines like Chevrolet's 427 or Chrysler's torque-rich Hemi. Throttle response felt soft. Acceleration seemed unimpressive. Drivers unfamiliar with the engine sometimes wondered what the fuss was about. But once the tachometer climbed, everything changed. Around 3,500 revolutions per minute, the Boss woke up. By 4,000 revolutions per minute, it pulled hard. Above 5,000 revolutions per minute, it became violent. Drivers described the power as explosive. The engine suddenly came alive, pulling hard toward its upper rev range with a sound unlike almost any other American V8. The exhaust note transformed from a mild rumble into an aggressive roar. Acceleration became relentless. One period road test described it as driving 2 different engines depending on where you keep the tachometer. Mechanics often joked, "It doesn't wake up until everyone else's engine is already going to sleep." But the race engines were even more extreme. NASCAR versions abandoned hydraulic lifters for solid lifters. Compression ratios climbed beyond 12:1, sometimes reaching 13:1 or higher. Intake systems grew larger. Aggressive camshafts transformed the personality completely. Race engineers installed mechanical lifters because hydraulic systems couldn't maintain stability at sustained high RPM. Valve springs became significantly stiffer, sometimes requiring over 400 pounds of pressure to control the massive valves. Push rods were strengthened. Rocker arm geometry was refined to minimize flex and maintain precise valve timing. Intake manifolds grew into massive single-plane designs. Carburetors expanded to 850 or even 1,000 CFM. Exhaust headers featured long primary tubes optimized for high RPM scavenging. Now the Boss could safely spin beyond 7,000 revolutions per minute. Some race engines regularly saw 7,500 revolutions per minute. That was extraordinary for a 7-liter pushrod V8 in the late 1960s. Most big blocks of the era became unreliable grenades above 6,500 revolutions per minute. Heavy reciprocating parts created destructive inertia. Valve train components failed, connecting rods broke, crankshafts twisted. The Boss survived because every component was designed for extreme duty. Still, engineering perfection doesn't come without pain. Early development exposed weaknesses. Valve train stability became a constant concern at sustained racing RPM. Huge valves created enormous inertia. Valve springs lived brutal lives. Engineers experimented with different rocker arm geometries, revised spring pressures, and stronger push rods just to keep everything under control during 500-mile races. Early prototypes experienced valve float. That's when valves can't follow the camshaft profile at high speeds. The results were catastrophic. Valves collided with pistons, springs broke, rockers fractured, engines destroyed themselves spectacularly, sometimes scattering parts across the track. Ford's engineers methodically eliminated each failure mode. They revised valve spring wire diameter. They changed rocker arm ratios. They experimented with titanium retainers to reduce reciprocating weight. They tested dozens of pushrod designs, seeking the perfect combination of strength and flexibility. Heat was another enemy. Massive combustion chambers generated incredible temperatures. Cooling passages inside the heads required careful refinement to prevent localized hotspots that could trigger detonation. Uncontrolled explosive combustion was a race engine's worst enemy. It destroyed pistons, it cracked cylinder heads, it ended races. Ford's engineers spent countless hours reshaping water jackets and adjusting coolant flow. They used thermal imaging to identify problem areas. They modified casting designs to improve water circulation around critical zones. They tested various coolant mixtures, seeking optimal heat transfer. One engineer reportedly remarked, "Power wasn't the hard part, keeping it alive was." That work paid off. In 1969, Ford teams began showing serious speed. Drivers like David Pearson and Bobby Isaac extracted incredible performance from the new engine. Pearson, driving for Holman Moody, became one of NASCAR's dominant forces. His smooth driving style perfectly complemented the boss's high RPM power delivery. Bobby Isaac, behind the wheel for K&K Insurance, captured the 1970 NASCAR Grand National Championship. Isaac was relentless. He won 11 races that season, finished in the top 5 32 times, and led the points from start to finish. The Boss 429 gave him the power to dominate superspeedways while maintaining enough reliability to finish races his competitors couldn't. At Talladega in 1970, Isaac set records that stood for years. His qualifying speed exceeded 201 miles per hour. Think about that. A full-bodied stock car in 1970 breaking 200 miles per hour. That was the Boss 429's doing. The Boss 429 became a winner almost everywhere it raced. At tracks like Talladega and Daytona, its combination of horsepower and durability proved devastating. The engine delivered relentless top-end speed over hundreds of miles without the catastrophic failures that plagued many rivals. Chrysler's Hemi made incredible power, but it faced reliability challenges. Chevrolet's engines were strong, but couldn't match the Boss's breathing. Ford had finally built the weapon it needed. And that's exactly what Ford wanted, because endurance wins championships. Raw speed matters, but finishing matters more. NASCAR races weren't drag races. They were grueling endurance tests where engines operated at maximum output for hours. Components experienced thermal cycling, vibration, and stress that revealed every weakness. The Boss proved it could survive, but another problem was quietly growing inside Ford headquarters: money. Every Boss 429 streetcar represented an accounting nightmare. Only about 859 examples were built for the 1969 model year. Another 499 followed for 1970. That's a total production of just 1,358 cars, 2 model years, barely more than 1,000 cars. Each one required expensive hand modifications, specialized labor, unique parts, low-volume manufacturing. Nothing about the project made financial sense. Ford's accountants watched the program bleed money. Every spreadsheet showed losses. Every quarterly report highlighted the Boss 429's negative contribution to profitability. Executives questioned the wisdom of continuing such an expensive program for so few cars. Even the sticker price reflected the complexity. A new Boss 429 cost around $4,900 to $5,100 depending on options. That was serious money in 1969, equivalent to well over $40,000 today before inflation adjustments for collector value. For context, a standard Mustang fastback started around $2,800. The Boss cost nearly double. Meanwhile, buyers could purchase other muscle cars delivering similar straight-line performance for significantly less. A Chevrolet Chevelle SS 454 cost less. A Dodge Charger R/T 440 cost less. Even Plymouth's Roadrunner with its standard 383 or optional 440 undercut the Boss significantly. Smart shoppers looking for pure quarter-mile performance could find cheaper alternatives. The Boss wasn't built to maximize profits. It existed to satisfy NASCAR, period. And then, the rules changed. By the dawn of the 1970s, the muscle car era faced pressure from every direction. Insurance companies dramatically increased premiums for high-performance cars. Young drivers, the core muscle car demographic, suddenly faced insurance costs exceeding their car payments. Parents refused to co-sign loans. Dealers watched their most profitable customers disappear. Federal emissions regulations became stricter. The Clean Air Act demanded cleaner engines. Catalytic converters appeared on the horizon. Automakers faced massive fines for non-compliance. Compression ratios began falling across the industry. Leaded high-octane gasoline was disappearing. Engines designed for 100-octane fuel suddenly had to run on 91-octane. Detonation became inevitable unless compression dropped. Power figures plummeted. Corporate priorities shifted. Safety regulations demanded expensive crash testing. Fuel economy standards threatened to penalize gas guzzlers. Profit margins contracted across the automotive industry. Ford executives started asking uncomfortable questions. Why continue building one of the most expensive production Mustangs ever created when the market was shrinking? How could they justify hand-building low-volume specialty cars when federal regulations demanded massive investments in emissions technology? The answer was simple: they couldn't justify it anymore. The business case had evaporated. NASCAR still allowed the Boss 429, but the street car requirement became impossible to defend financially. Production ended after 1970. No announcement, no fanfare, just silence. One day, the Boss 429 existed. The next day, it was history. Ironically, the engine itself continued evolving in racing long after the street program disappeared. The Boss 429 architecture eventually influenced Ford's legendary semi-hemi racing engines throughout the 1970s, proving the original engineering concepts had been absolutely correct. The canted valve design, the big port heads, the over-square bore-stroke ratio, everything Ford's engineers created for the Boss became foundational knowledge for the next generation of racing engines. The street car died, the racing DNA lived on. And then something nobody expected happened. Collectors discovered what Ford had accidentally created. Because only 1,358 production cars existed, surviving Boss 429 Mustangs became extraordinarily valuable. Their rarity alone guaranteed desirability. But rarity wasn't enough. They represented something deeper. A moment when accountants temporarily lost the argument. When engineers were allowed to chase victory instead of quarterly profits. When an automaker willingly spent enormous sums simply to beat its rivals on Sunday. Today, pristine Boss 429 Mustangs routinely sell for hundreds of thousands of dollars. Exceptional examples have crossed the auction block for well over $500,000, while historically significant cars, particularly those with documented racing history or unique provenance, can command even higher prices. Barrett-Jackson, Mickham, and R.M. Sotheby's regularly feature Boss 429S as headline attractions. Bidders compete aggressively. Prices continue climbing, not because they were the fastest muscle cars ever built, not because they were the most comfortable, not because they were practical, but because they symbolize an era when engineering ambition outweighed financial logic. Even modern engine designers still admire elements of the Boss architecture. Its high-flow cylinder head design, enormous breathing capacity, and race-focused combustion chambers demonstrated ideas that were decades ahead of many production V8s. It proved airflow matters. It proved efficient cylinder filling creates power. And it proved that sometimes the best engineering solution isn't the cheapest one. Ford's modern Coyote engines carry lessons learned from the Boss. Canted valves, big ports, high RPM capability. The philosophy persists even as technology evolves. That's why enthusiasts still speak about the Boss 429 with almost mythical respect. Because underneath that shaker-free hood wasn't just another big block. It was Ford's declaration that losing wasn't acceptable, even if winning came at an impossible price. In the end, the Boss 429 didn't fail because it lacked power. It didn't disappear because it couldn't win races. It disappeared because building greatness cost more than the market was willing to pay. And that's what makes its story so unforgettable. The Boss 429 won championships, reshaped Ford's racing future, and became one of the greatest homologation engines ever built. It stands as proof that sometimes the most successful machine on the track can still lose the battle in the boardroom. But maybe that's exactly what makes it legendary. Not despite its commercial failure, but because of it. Because Ford built it anyway. Because engineers refused to compromise. Because for one brief shining moment, racing mattered more than spreadsheets.